My name is Eric Lagerway, the chair for the ORTC Community Group. Welcome to meeting number 7. This introduction has been truncated due to technical difficulties.
So the next question is, what do you do about P time? So Magnus had a summary on the WebRTC 1.0 mailing list about all the issues with P time. Basically, it's somewhat specific to each codec. And so one could think of it as the capabilities being an array of P times that, say, the decoder could support, or I guess the encoder could encode with. It is, I guess, a little bit complicated because you can support, there's the issue of the P time in each individual, you can have multiple frames, of course, in a packet, so then you have the P time setting, which would indicate what you're actually encoding at, for example. We haven't put this into the spec yet in each of the codecs, but this is kind of the proposal for how to do P time. And when Magnus indicated he thought it was useful to be able to exchange the potentially P time capabilities and be able to change them on the fly, because that could be potentially used for rate adaptation in something like G711, which really doesn't have any other way to adapt rate.
Yeah, I think that's all true, but I would sort of caution that this is a fairly advanced behavior.
Yes.
And well, I think it probably makes sense to have P time as an encoding parameter that can be set. I think the actual true need to be able to configure this is pretty low, and I haven't really seen any push in WebRTC 1.0 to really say, hey, we really need to do something here.
Oh, okay. So so you don't think the implementations will actually do it either on the encoder or the decoder on a codec-specific basis?
Well, I think in WebRTC 1.0, we just don't have the control surfaces, and so even if we wanted to do it, it would be really hard. And so here, I think we at least have the option to do it right. But I just think we should just be aware of the fact that this is, despite Magnus's email, this is probably going to be a corner, an edge case, a 1% feature.
Yeah. Yeah. I guess the only real question is, should we put? It would also be a per codec thing, I think. There's certainly no requirement that every codec have it. So I guess maybe the right thing to do is to talk about, like, for example, Opus capabilities and parameters, and just see what people want to have in there.
Maybe.
Yeah.
I mean,
it isn't listed currently as in the Opus capabilities or settings.
Well, enumerating all the capabilities that supported, P times, this could be very difficult. You could even imagine some codec that has, supports an arbitrary number of samples per packet or something.
Right.
And so, like, how would you represent that? I think that where we're at right now, where if we have a max P time, as you're indicating for the capabilities, and that allows us to, like, generate the rate STP and the shim, and then some sort of P time, thing for the encoding parameters, where if you know what you're doing, you can control this and you can drive it down to 1 millisecond or whatever. But typically, people will just leave it unset, and you'll just get the behavior you have today.
Yeah. Okay.
So do you think that the settings should be changed from max P time to P time?
No, I think
No.
There's two things. There's the capability of max P time, because that's really the thing that needs to be signaled. But then the actual setting of what you send should probably be P time. And if you want to do, like, musical performances, where everybody is, having to send packets as fast as possible, then someone can specify 1 millisecond for P time, and that should be probably an encoder parameter.
So the proposal that was on the previous slide had max P time as capability, and then max P time as setting.
Right.
So you're saying max P time for capability, that's good, but maybe tweak it a little for the setting.
Yeah, I'd say it should be P time probably for the setting, and then you could explicitly say, I want 1 millisecond because I want really low latency, or I want 80 milliseconds or 50 milliseconds because I want minimal packetization overhead.
But is it enough to say max P time 1 or max P time 80, or does it?
Well, because if you say max P time 80, you could still send 1 and be compliant, right?
That's true.
The P time can get really complicated very fast with all the different possibilities and capabilities. So I think just having the capability for the sake of the SDP would probably be sufficient. I'm not sure that we actually, aside from codec specific definitions of what the P time values should be or set of P time values should be, I think we should just kind of leave it alone and just have the capability.
So that the capability, as you say, is the one thing we have to do, and I think we all pretty much agreed the max B time thing on the capability is like the right solution there. So we should at least like agree on that and move forward, and then we should separately consider should having a P time parameter on the encoder. Is that something that would also be useful for more advanced scenarios? But that's definitely not a 1.0 requirement. So if we wanted to revisit that in the future, we could certainly do that.
Okay.
So going back to the previous slide, we agree on the first part, but we will punt on the second part? Is that?
+1 that myself.
Okay, so just remove the max P time from the codec parameters.
That works for me. I'll just update the bug, which kind of some of the discussion that we just had.
That'd be great. Thank you.
And then like when we revisit it, we can kind of like start from there.
Okay.
But actually, if we remove the second one, what if the remote end gives us max P time less than our local capability? Do we need to honor that?
Oh, that's a good point.
Oh, yeah. You get the capability, but then what do you do with it? You got to push it down to the other side somehow.
All right. Then that means if we do the both ways, then that means we also need to have encoding parameters. In this case, does it mean the receiver should be able to decode any packetization less than max P time?
Maybe what we can do is leave the max P time on the parameters, and that's just used to basically push down what the remote side can do.
Well, but hold on a second. The capability, I believe, is the max P time for the decoder, right? So it's not kind of a union. Each side is saying my decoder has a max P time of X.
That's right.
So the fact that one is lower than the other, that's just a statement about each one's decoder. It's not like, you see what I'm saying?
So you tell me you can do a certain max P time, and now I need to push that down into my RTP sender.
Right, into your sender.
So that I don't go over that. So
right, in your sender.
if we leave it on the parameters, I'm capable of doing that. But then this extra case where Justin's talking about wanting finer control, that's what we can punt on.
Right.
Yeah, I agree with your statement, Peter. I think as is, it works. So.
Yeah, we probably should actually have a little language in the spec too to just explain all of this. But so we're basically keeping the proposal for max P time, is that right?
Yeah, and it has
shouldn't be just P time, not max P time?
No, because max P time has a different semantic than P time. And I think max P time is the semantic we want here.
It's the semantic in Jessup, so.
Right. I mean, basically, the capability is the max P time from your implementation, and then the parameter is, here's what the other guy sent me. I'm going to stuff this in so I don't do anything that the other guy can't do. And it's, if the other guy says max P time of 100, you don't have to do 100. It just means you can't go over 100. Whereas if we had a P time parameter, that would mean do 100. Does that make sense?
Yeah.
It does to me, Justin.
All right, I will try to codify this into bug number 160.
Okay, so let's move on. Okay, so unhandled RTP streams. There is a pull request in W3C 1.0 for something called the RTC media discarded event. I don't think the pull request got merged, or there was some kind of merging problem. But anyway, it says it's fired to indicate packets of an unknown SSRC payload type or other error that makes it impossible to attribute an RTP packet to a specific track. So we've gone ahead and taken that pull request and edited the RTP unhandle event to basically use the same parameters, the same attributes, SSRC payload type and mid. So it's now compatible to that extent. But then a question came up, well, what's the difference between a media discarded event and an RTP unhandle event? Should they be the same name, or is there some difference that's trying to be indicated by the difference in names? So the answer, at least what we thought about, is that at least the spec as it states right now, there's no requirement that the RTP unhandled packets be discarded. there is the ability to have some modest buffering. Now, when I say modest, one of the cases that people would be concerned about is a kind of a new video stream showing up. And in that case, you could be receiving an iframe, which could be hundreds of packets. And it's very possible that you wouldn't have the buffering to actually receive the iframe, and it basically gets thrown away. So the buffering doesn't necessarily mean that it isn't. There's no guarantees that it'll actually work, but basically the difference, I think, is that in ORTC there's no requirement that the unhandled thing be discarded, but it doesn't mean basically you could buffer or you could throw it away.
But even in 1.0, is it required to not buffer? I mean, I know it's called discarded event, but
yeah, well, that's a good question.
Does it say must not buffer?
Well, actually, you can just check the pull request and see what it says.
Well, I looked through it.
Didn't say either way?
It uses the word discard, but it's not like precisely clear whether that means I'm just not doing anything with it, or I'm really throwing this away and pretending I never got this. I'm definitely not buffering at all.
I agree, except the name really strongly implies that it is thrown away.
Yeah, so I guess the question is, are these events really the same or not? Or should they be the same?
I think they're basically the same. It's just a question of, like you said, whether is it fully discarded or are you allowed to like remember it for a little while?
Mm-hmm.
And you know, we already have code in Chrome that does a modest amount of buffering.
Mm-hmm.
So, I mean, would we go delete that code just because it's called the discarded event? I'm not sure.
Yeah, I don't see any reason to.
So the question for us is, do we want to adopt their name, or do we want to try and influence them to say that's a bad name because it doesn't do it in Chrome? Or do we want to, you know, just adopt their name and put a caveat saying it's allowed to be buffered even though the name implies that it's not?
Well, I think if an implementation of ORTC buffered and then you shimmed on top of that Web 1.0, I don't think that's going to cause a serious problem.
No. It's just, yeah.
Do you want to use their name then, even though it's not buffered?
If there's no real...
If we're not... I prefer this name.
Yeah, I prefer it too, because particularly given what it does, it's more descriptive.
I think if I had my preference, I would prefer to try to go back to the 1.0 and say, hey, can we have some modest buffering and can we name this something a little different, rather than... I mean, it's just a pull request right now. It's not actually...
Actually, and it didn't get merged.
Right.
Okay.
So
fine with that.
Peter, do you remember the sort of discussion around this of why we came to this, you know, sort of idea that we should have the discarded event instead of like unknown streams?
No, I don't know. I don't remember why. I don't remember even any discussion about discarding versus not discarding, or buffering versus not buffering.
And my recollection was a little bit different, that there was the ability to have unknown media streams that would then result in a event that you could then grab that stream. But there were things where you could receive stuff that was just garbage and you had no idea how to deal with it, and that would lead to the discarded event. And this is more for debugging rather than actually trying to generate a stream then you could then, you know, do something with in the application. So I was typing up the bug thing for the p time, so I didn't catch the first part of this discussion. But I think there's two separate things. One being that RTP stream arrived that didn't have any like signaling stuff, and that's one event. And there's you know, packets arrived that were screwed up, and we want to let the application know because, you know, it should go debug this, and that's the media discarded event.
Oh, so what's in 1.0? What's the other event called? Is it already there?
Well, it basically says having an unknown SSRC payload type or any other. It includes any other error that makes it impossible to attribute an RTP packet to a specific media stream track. Sounds like it combines both of them, but.
Well, I was under the impression that's supposed to be unrecoverable. that, like, since we're discarding the packets, as you mentioned, the whole point is that these things are going to the bit bucket, and we're not going to try to, like, produce a stream that if the application decides to actually pick it up and hook it up to something, we'll actually be able to start playing out. And, like, Peter, I know you mentioned we have some buffering in the Chrome code right now, and that's around that second semantic rather than the semantic of you got some garbage packets and we want to let you know about this.
So I see the value in having two separate events, but does WebRTC 1.0 have two separate events?
I think further investigation is needed, but I was pretty much of the understanding that. Well, that's a good question. I mean, I think WebRTC 1.0, was definitely predicated on the notion that you would have a separate M line for each stream, and then if the package showed up that if you didn't have an M line for it, you would get this discarded thing. I think that you might not have WebRTC 1.0 allows you to omit the SSRCs, and so if you have an M line but no SSRCs, you should be able to lock onto that properly. But it's not clear that you can have. What happens if you have a single M line and you start getting two different SSRCs, for two different video streams? I think that the second one would drive this media discarded event. Bernard, do you remember that discussion? I thought we talked about this.
Yeah, I do remember talking about it, and maybe my impression was it was mostly about the not having the signaling, and I also raised something on the list, and Martin basically responded in a way that made me think that it was similar to RTP unhandled, but probably Martin's the right person to ask.
Yeah, I think we need to kind of, Martin's the author of this PR, we need to sort of follow up with him and find out, well, what should happen, like in the case we just talked about. You have one M line, the video M line, and you have two SSRCs show up. Does the second one trigger some other event, or does it always trigger this on media discarded?
Yeah. No, because there are, at various points we've talked about other streams that can come in where it's not just an issue of unknown SSRC, like something else is screwed up, like it's some layer you didn't expect or some weird thing like that, and that wouldn't be probably an RTP unhandled event. Yeah.
So I just went and found some IETF list, W3C list history on WebRTC 1.0, and Harold closed the bug saying, "We gave up on the ability to handle inbound media prior to an answer arriving." And then a little bit later, Martin sent out the pull request with discarded. So
what did Harold say exactly?
So Martin filed a bug in 2013 saying basically we want to be able to handle some way media before signaling. And Harold closed it, saying, "As far as I can tell, we gave up on this."
And then he filed the pull request, and then it didn't get merged. I don't know. It wasn't rejected, I don't think. But.
And then a couple months ago, back in November, Martin filed a pull request for the discarded event. So there may have been more discussion that's not here in this bug, but
okay.
At least what the bug says. I'll post the link here.
Okay, and I guess the resolution is to talk to Martin and figure out if we need some other event. But at least right now, we're not going to change the RTP unhandle event.
Sounds like we might have to add something.
Right. Might have to add some other event, but.
Okay, I think that's all we can do for the moment, is to get to the bottom of 1.0.
All right, so other changes, which are not 1.0 ones. There was an editorial one where we changed, because we basically we left an ICE transport event for new candidates in the transport instead of moving it to the gatherer, because that's where the candidates, local candidates are now. So we fixed that editorial issue. We added matching rules as proposed by Peter, and we're going to have a lengthy discussion on that. There was discussion of automatic use of scalable video coding from the last CG. and we added some text for that, I think as proposed by Justin. Add a little update to the big picture. We had a bunch of issues relating to ICE, which Robin is going to get into, including a lot of them, both for DTLS and ICE, they relate to what happens if you get connectivity checks or get DTLS packets before you call start. So we'll talk a little bit about that. And then there was a question about ICE consent. So most of these we will have a discussion of during this session. Next. Yeah, so this is the new big picture. The difference is we have more arrows relating to candidates. There's candidates coming out of the ICE gatherer, but there's also remote candidates being pushed down into the transport. So we have arrows going from the JavaScript to the transport as well.
So we probably should have go back over the. So the line that's if I could have colors or something like that. The line going down from the sender to the ICE transport, that's candidates, right?
Yeah, wait. I couldn't get the letters. We couldn't put text next to each of those lines because it just got too small. But yeah, those are all of those 4 lines down and up are supposed to be candidates. There's a better way to.
Maybe you could put maybe you could put candidates and then a C in parentheses and then put little C's next to.
Little C's next to them, yeah.
Maybe we could just have dash lines or something to indicate candidates or something, and
Yeah, that'd be better.
Have a legend. Hey, I mean, look, that was complicated,
It's a slippery slope.
All right, thanks.
So I guess there's a couple of questions for the CG. Is the CG generally okay with the direction in which the editor's draft is headed thus far? Haven't had a lot of pushback up until this meeting, so I'm not sure why that would change. There's not been a lot of controversial stuff handled here. Do you have any questions about the general aspects of the spec? If so, you can send them to the list, or if you're on the call now, you can bring them up. For discussion today, ICE-related issues on the issue tracker 164, 166, 170, and 171. DTLS demuxing upon second start, and matching rules. Coming attractions, DTMF, if 1.0 gets around to it, and IDP for the same reasons, and data channel for the same reasons. ICE Gatherer State Candidate Pruning, issue 164. Take it away, Bernard.
Okay, so there was a little bit of confusion relating to the gatherer about whether it was affected by the transport or not. So when the transport prunes candidates, did the gatherer lose candidates or not? And I think Inaki brought it up. So in general, so they put in a clarification to say that if you prune the local candidates within the transport, it has no effect on the candidates available within the gatherer. Having that kind of a side effect would be a bad idea because it would affect forking. So you'd, for example, have one fork that was pruning candidates and it would affect the candidates for another fork. And that would basically mean you'd need to create another ICE gatherer for the other forks. Each fork would need its own gatherer, which is kind of against the point of creating the ICE gatherer to begin with. So basically, even if you prune candidates, the stuff in the ICE gatherer, candidates in the ICE gatherer remains the same.
Okay.
So hopefully it's surprising.
So how then do candidates owned by the gatherer then get released? Is that just like a reference canning sort of thing where if both transports prune?
Well, I mean, if an interface goes down or something, then candidates can be removed, and basically that will affect all forks because the candidates, it's dead, right, in all forks.
I see. You want to talk about the local candidates?
Yeah,
here?
this is only local candidates. Yes,
yeah.
That's all that's in the gatherer, right? Is the local ones.
Yeah, and there's another issue as well, is you also don't know how long it's going to take for all the answers to arrive when you make an initial offer. So it could be that you actually need to keep your gatherer warm for an X amount of time before it's even allowed to be released, and that's something we don't actually address right now. So I see that as a separate issue myself, and that's something we do definitely need to address.
Yeah, I think the assumption here is the gatherer keeps the candidates that are available, whether they were pruned or not. It's just kind of the pool. If an interface goes down, you take them out. If a new interface comes in, you get a new one. But it's not affected by the what's going on in the transport.
Right, and also there's also the question of the turn allocations and whether those should remain warm or be shut down after a period of time based upon usage. And it might be that we want to have it where when you do a gatherer that it remains alive and active for a period of time specified, and then if they're not used by any transport after that time, they can go to sleep and be turned down.
So does it mean there's no deterministic event or APIs we can rely on to really prune the ports? Does it mean we have to keep a turn port out for all the calls ongoing, even if the calls are local?
Well, no. I mean, the transport can prune its candidate pairs. I guess the way to think of it is the transport's making a copy of these candidates, right? It's not it can prune within its own transport, but it's not affecting what's in the gatherer. So there's no interaction between forks. If one fork pruned the candidate pair, it's not affecting candidate pairs in some other fork.
But that's still, like, for example, the port open on the turn servers, they have to be kept alive in the duration of any call.
If it's in use, then yes, it must be kept alive. The gatherer needs to. That's certainly clear. What's not clear is how long, when it's not in use, it should remain alive, especially when you're making some offers. And if you want to make some new offers later, you need to be able to warm them back up so that you can reuse the same gatherer in the future.
So, okay, so let's go to a WebRTC 1.0 a little bit. In the final answer, it's quite okay part. In theory, we should be able to pull all of the ports not in use. So map to ORTC, so we cannot really do anything. We have to leave the ports open.
I'm not actually hearing you very well. Is it just
sorry.
me?
Yeah.
What I meant is, just think about the scenario we Intel with a WebRTC 1.0 implementation. And on our local side, we keep ports open, our local candidates. But there isn't any guarantee remote and keep things do the similar behavior, have the similar behavior.
Oh yeah, I get your point. That's another problem that we face is we do not have an ability to be able to predict the behavior of the remote side. And that's also because we don't have control over what the local side is doing so that we can predict the remote side as well. So that is even another issue that we have to sort through.
Yeah, but not this issue.
Yeah, it's not this issue. Like, I think that just sticking to the 164 issue alone, I think it's clear that the pruning of the transport does not affect the gatherer, but we still have the issues of the other several issues which we need to create new issues for.
Yeah. Well, we have plenty of issues, so. Okay, so next one.
So just a sort of one final comment. Like, if you did have a gatherer, it gathered local candidates and it gathered turn candidates, and then the transport, negotiated, finished, and got rid of the turn candidates, those would also get removed from the gatherer, right?
I don't necessarily think so, because if you have an outstanding offer that is out there that is later going to receive an answer, because it might take some time to receive all your answers in. It might be that one fork will not use the turn and another one will. So there's a question of timing.
But you would need multiple ICE transports in that case.
Yeah,
yes,
you would have multiple ICE transports.
But still one gatherer.
But that wasn't the scenario I was talking about. It's like where you have just a single transport and it finishes, then it, since basically the turn candidates no longer have a reference for any transport, they would get culled.
The problem is you might not know to open more transports in advance because you may not know how many answers are actually going to come back. So even though you start with one transport potentially, and it has all references gone, there may be another transport that has to be created later. So there is a timing issue even then.
So how are we going to deal with that? I mean, otherwise, like, we're going to leave the turn candidate lying around forever.
No, I think that there could be a simple solution that for example, we could have a method called gather on there, which you specify a duration, saying I need these alive for this period of time, and then you can shut it down. And in other words, I expect all my answers to come in within this time period. That could be a simple solution to that.
Yeah, I was assuming there was some kind of default lifetime within the gatherer where all the turn candidates would just go away.
Wouldn't it be better to have an API call to basically say that we no longer need any...
30 minutes, timeline.
Yeah, that's another alternative, is to have an actual API call instead of a time where you say now it's okay to shut down because you knowingly are no longer having any more references. So there's several possibilities. But again, we need to open a new issue on that, I think, to discuss it.
Another option, while we're talking about options, might be to have the JavaScript create a number of ICE transports and then link the ICE transport somehow to the ICE gatherer before calling start. We have a similar problem with responding to connectivity checks.
Yes, actually, I agree, Peter, that there's a whole bunch of things which are affected by only having the linkage at start. So yeah, that is it's worth thinking about.
So what specifically, is this thing? We're not talking about the handling of turn candidates. Is this 164 only handling the local candidates?
Yeah, it's purely people asked what candidates are in the ICE gatherer. Is it affected by pruning or not? So it's only about the local candidates, which is all the ICE gatherer deals with.
You mean local candidates means the host candidates, or actually including the local side turn ports?
All the ICE gatherer handles all the local. The only candidates it doesn't have among local candidates are peer reflexive.
Oh, okay. So when you said local, I thought you meant host.
Yeah, it's not just host.
Right. So I think this is fuzzy because if the ICE transport, if the ICE transport finishes and prunes its candidates, then the gatherer needs to prune any unreferenced candidates, and we still can debate exactly how that should work, but I don't think we can say that the ICE gatherer never does any pruning.
No, I think a question is just a question of when. Is it a timeout? Is it an explicit link between ICE transports? That's the question, is when.
Right.
Yeah, I agree with Peter.
I think the answer isn't never. It's just
right.
Well, I think having it as a timeout is kind of weird. I think that what we should do, if you think you might still get more answers, you should prospectively create new transports, and then if you turn out not to need them, then the application can throw them away whenever it feels like it. But
that's what I was suggesting a minute ago.
Yeah.
But then we need a way to link the ICE transport to the ICE gatherer before calling start.
Right. That's the issue right now.
Which is the exact same problem we have with the responding to connectivity checks.
Exactly.
Or we have an API, new API to really get out the prune. That's what I also look at. Basically, timeout doesn't look like very reliable what it needs to do. Right? Probably have a receive API, and that means most likely when we receive final answer, you probably can just call this API after whatever.
Yeah, there could be an API just to say I'm no longer, gather now, and then after you're done gathering to say it's okay to clean up. Or you could do it through timeout. There's different ways to do it. I just think I think this is a separate issue from this. I think we need to have a specific issue open about that and have a discussion.
Yeah, we might want to go to the issue about responding to connectivity checks.
Yeah.
And then come back.
That's coming up. Which one is this?
Because it's related.
Yeah. Is it the next slide?
No, it's 2 slides down. It's not.
Yeah, it's 170. Yeah, this is it.
So go ahead, Bernard, and explain this one.
So the question arose: hey, does the ICE gatherer respond to connectivity checks? When do you start responding, and when would you initiate? And so, in theory, the ICE gatherer has the local password UFRAG, so it could respond to a connectivity check prior to the calling of ICE transport.start. And so the proposal was for it to say it may respond, but there's a few issues there. One is that it can respond to the checks, but it can't initiate. The ICE gatherer doesn't have the remote password UFRAG, so it can't initiate connectivity checks. And so, as Peter mentioned on the list, there can be a weird situation where it's responding to the checks. One side thinks everything's okay, but start never gets called. And so then you end up with this kind of half connection. And then the other thing is, it also is possible for there to be a time lag. Like if you look at the sample code, the gatherers get created, the ice transports get created, and they're used to call get local parameters for the signaling. And then you have the signaling, and only after the signaling is finished and you figure out whether you're doing bundle or RTP, RTCP mux, does .start actually get called. So the ice transport .start can get called, substantially after these transports were created and the gatherer was created. And that means that you might respond to a connectivity check, but then wait some period of time before actually initiating the connectivity check. And that's kind of against the spirit of what 5245 recommends as an optimization. It says you should pretty much start the connectivity check right away. So those are some of the weird things that can happen. The alternative is not to respond to the connectivity check, let it maybe retransmit, and then it only can respond once .start is called from the ICE transport. So that's what this issue is.
So I sent an email. I think there are 4 options. One of them you mentioned, which is discard them, and one of them is to respond from the ice gather. Another one is to remember that you got the connectivity check in the gather, but then only send the connectivity check response in the ice transport when ice transport start is called.
Right.
And a fourth would be to somehow link an ice transport to an ice gatherer before you get the remote's parameters, and then that ice transport can respond to the ice connectivity check. So we would need some method that links a gather and a transport before you have the remote parameters.
Yeah, so linking them, it can respond, but again, before .start is called, it doesn't have the info to initiate its own, so you still can have that weird lag, even in that case.
So what's the real downside besides the time delay of responding immediately?
Well, if it's would only be if the application lets it go, I think, for a really long time. It's just something the programmer has to be aware of, right? I mean, I don't think it would cause an enormous problem. It would be kind of an extreme case, like if there are a lot of retransmissions of the offer and then a bunch of retransmissions of the answer or something, so it got so long that it actually, a NAT binding closed or something. I don't think it's like a huge problem.
I see. I mean, I think the easiest thing is to just allow the gatherer to respond to the checks because it doesn't need the remote credentials to do so.
Right.
I would actually agree with that because in reality, in signaling, you still need to validate that you received an answer, so that you still need some sort of signaling to tell that you actually run the start. So there is no big harm in responding to the ICE checks. You should not be using them as the only indication that the remote party actually started the channel.
One question, I would agree except for one question that I have. If you're the sending party and you're trying to send to the remote side and there's a connectivity response, I believe, and correct me if I'm wrong, that you're allowed to send the moment that you receive a response from the remote party. So that could mean that RTP effectively starts arriving really early from somebody you may not even want.
Well, you still have to do DTLS, don't forget.
Right, yeah.
Right.
But yeah, you can send. You certainly can send as soon as you get the, as they get their binding response, they can start sending.
But do we need to this multiplex to be set up before we send any RTP? I forgot what else you were actually specified or not. Do we allow to one direction set up, the other direction hasn't been established? We allow RTP to flow.
Well, in this case, it won't because of Justin's point about the DTLS. Would it complete? No, it wouldn't because
it can't complete before DTLS starts.
It can't complete, but you can start the DTLS handshake.
Yeah.
Yeah, but in general, I think we also agree that so basically just like gather reply to the probe. That's okay. That's actually, I think it is right.
So what if the remote side creates an ice transport, it sends a connectivity check, we respond with the ice gatherer, then they take a DTLS transport and start the handshake. Now what happens? Does it just get dropped until the local side creates an ice transport and a DTLS transport?
Well, unless there's a DTLS transport, the incoming DTLS negotiation, there'll be nothing to receive it.
Right. We can't send DTLS packets back until we've sent our own connectivity checks.
Right, but we'll be in the same situation where do we just drop the DTLS packets that come in, or do we buffer them and wait until...
Yeah, there's another issue on exactly that, on exactly that point. And the suggestion is that it be buffered. I don't remember exactly whether it was I don't think it was a must or anything, but...
Yeah, I mean, right. I think we deal with that in the other issue, but I think the default timeout for DTLS handshakes is like 1 second, and so like we could end up waiting for an entire second until we actually would do something. Send like get another packet if we didn't actually buffer it.
Okay. So just as a question, it sounded like people were okay with the gatherer responding to the check. It's only a may now. It's not a must or anything. Is that the appropriate word?
I think that it should must. I mean, I think that generally speaking, we've gotten ourselves in trouble with non-deterministic behavior. We should try to be very explicit.
I agree with that. It should be a must.
Okay.
Otherwise it's something.
Yeah, it should stay consistent.
So it must buffer or must respond?
Must respond.
Right.
Yeah, I mean the buffering is also important. Well, we said it's got to give it to the ICE transport to say, hey, I responded to this check, so the ICE transport can actually initiate when that start is called.
But the implication here has an impact on DTLS, and so we are pushing the problem a little bit higher up now.
Well, this stuff is complicated, right?
Yeah, no, I totally hear you.
Yep.
Yeah, well, for DTLS, it's basically a must buffer, and for ICE check, it's must respond. And
Okay.
just keep a flag that it responded to an ICE check.
Yep. Okay, so this one is 166 is about ICE restart. And it's trying to clarify a bunch of different cases that can happen. Peter mentioned that some of them aren't as clear as they could be. But so the first case is you call ICE transport.start with the newly constructed ICE gatherer. And that represents a classic RFC 5245 ICE restart. So you flush all the remote candidates, you adopt all non-pruned local candidates from the gatherer, and you use a new UFRAG password. So another one, which wasn't particularly clear from the text, was if you call ICE transport.start on a same ICE gatherer that you used before. So it's like ICE gatherer 1, and you call it again on ICE gatherer 1. And that still flushes all remote candidates and releases, and so it uses the existing UFRAG password because this is an existing gatherer. And I guess the point there was that calling ICE transport.start doesn't like magically change the UFRAG password on the ICE gatherer. But other aspects of the behavior are somewhat undefined because this is kind of the, I guess, the ICE restart light case, which there is no protocol spec for. And I guess, well, it says in both cases the existing nominated pair remains in use. That's, I guess, the classic ICE restart until you find a new one. And then I guess you stay in the connected state. Does that make sense?
Mm-hmm.
Okay.
Does to me.
So what's the sort of scenario we're envisioning for this number 2 scenario where we use the existing ICE gatherer?
I think in that case, everything's gone disconnected. It's probably more likely that everything's gone disconnected and we need to restart from scratch, but we don't want to renegotiate, like do a full ICE restart.
But help me understand, how does the application know that that's the right action to take?
It doesn't really know right now, unless it goes to the disconnected state.
Well, one other thing to consider is in a lot of cases when you do those restarts, you kind of want to collect new reflexive candidates at least, because very often your network connectivity options change. So doing this light restart might be somewhat dangerous to people.
Yeah, particularly, I mean, from what we just talked about, right? Maybe a reflexive candidate's timed out or something. So I agree with you. It could be dangerous. Because also we said basically, yeah, the problem is we're not talking about whether any regathering occurs. We just kind of said you have what you have in the ice gather, and it might be old. It might be, stuff might have expired. So it's maybe not such a great idea.
I mean,
Well, the gatherer wouldn't have pure reflexive, but it would
Right.
have server reflexive.
Well, it might not though, because it might the server reflexive it might have might be old, right? I mean, say you reuse a gather from like an hour ago. The turn candidates might be gone. A whole bunch of stuff might be gone.
No,
Well,
those would have to expire.
yeah, they're either expired or they're being kept alive, somehow. But most likely, if you've, not keeping a separate transport around like we talked about before, everything, all your local candidates will be the same as what the transport already has. And so like, the advantage, I guess, here would be that you could receive new remote candidates and you would clear out any existing remote candidates. But like that would be, I mean, like, there are other ways of handling that too. So it's not quite clear to me, like, when an application would do this.
Yeah, I guess basically we say it's a lot of aspects of behavior are undefined.
Well, I think we can define the aspects of the behavior that we want. I think we need to understand, like, again,
Why you care, right?
yeah, you define the situation where we want this, and then we can figure out what the right behaviors are.
I think this came up because it wasn't necessarily something that we expected people to do, but it's something that the object structure allows. So the
Right.
question just becomes like, well, now what?
Now what? Right.
Well, it's that, and also there are use cases around connectivity problems with mobile, especially with the Wi-Fi and 3G and 4Gs going up and down like yo-yos. So you do need to be able to swap between the various interfaces, and sometimes it can go to disconnected, and sometimes you want to go back from 3G or 4G back to Wi-Fi when it becomes available. So just because one becomes disconnected doesn't mean you don't necessarily want to go to the other. So that's part of the problem where we don't necessarily relay the continuous state of the remote gatherer to know when these interfaces come up and down. And that's some of the problems with a one-off, we're going to negotiate once and we're done scenario. It doesn't really necessarily work nicely for mobile.
Sure, but I'm not sure this solves that directly, right?
Yeah, clearly there's more work needed. I don't think this issue was trying to solve that problem.
For what it's worth, I think I could think of one possible use case, which is if I'm using my local client to connect to a remote endpoint that I know is a server, and the server has some kind of failover where it dies and it's going to transition to a new server, and it tells me that, I might be able to just change the remote side and leave the local part alone. Now, whether that's worth it compared to just doing a full ice restart, I don't know, but it's potentially one use case.
But if that's the case, do we need to redo DTLS? Then that means we cannot really restart ICE, but also we need to trash the DTLS transfer on top of it. In that case?
Sorry.
No, what I'm saying is, do we need to redo DTLS?
No. So yeah, we'll get to it in the DTLS one, but basically the way to think about it is DTLS is not really affected by ICE. Like, just because ICE went away or restarted or whatever doesn't mean that you have a new DTLS negotiation.
Right. So generally, I think that we should probably work downward from how do we want continuous nomination to work in ORTC.
Right. Yep.
And that will probably, all the right things will shake out as a result.
Yeah, and if we can handle those mobile cases well, I agree with Justin that this will shake itself out, and that's probably the right way to do it.
Yeah.
So when are we going to figure out continuous nomination?
You ready for a meeting this afternoon?
Yes, it's possible.
So I need to publish that document, but I think that at least I'll have some use cases where we can kind of look at those cases and see how those would map to API calls. We probably should keep rolling on this and sort of say that the ice restart. The behavior sounds fine. I'm not sure it's useful.
Right.
But we're going to have to revisit this anyway.
Okay. Yes, 171 was consent failure. Question came up: what happens if consent fails? And basically, we said the ice transport.state transitions to disconnected. That's it for this one. Okay, DTLS. So the case, I think, first brought up by Roman was that you have two DTLS transport objects constructed using the same ice transport, and you call start on transport B before you call transport A.stop. And you can't demultiplex these two different things. So what happens? Two alternatives. You throw an invalid state exception on when you call transport B.start, or Robin proposed that you have an implicit .stop on A. So those are the two options we have. I think a bunch of people said they wanted the invalid state.
That would be my preference too.
It's actually one other thing that I said was there is a third option. We don't allow to start a new DTLS transport on existing ice, on existing underlying transport again. Because even if you are stopping the previous one, if you had an existing DTLS flow, you can get packets which are arriving late. And once again, there is no way to demultiplex.
So we should think about what are the reasons we would bring in a new DTLS transport on top of a existing ice transport? And I guess one of the options that I was thinking about was that if we want to actually re-handshake, and there only seems to be some set of folks who want to be able to do re-handshake, during an active call. So do we have any other provision for doing that?
Not really. You can't call .start again on the same transport. So.
Well, so far on basically on SDP, the DTLS re-handshake should happen if the fingerprint or the roles change.
Right.
Yeah. Well,
so that's the provision, but I'm not sure anybody actually implements that, and if it actually works for anybody. So.
Well, it would never change in mid-connection, would it?
It can potentially. Like you can have an offer answer with the same ICE candidates, and you can have a different role. And currently, the RFC says that it will trigger the re-handshake.
Yeah. Well, in that case, yeah, you'd need the new transport for that.
But the issue is, again, I'm not aware of any implementations which can actually support that. And I'm not sure it can be implemented in a way that it's not discarding something or not doing something not nice to the existing data flow.
So is this issue more about supporting SDP, or is this issue about real-world use cases where we want to, for example, start with one server and then swap over to another mid-call using this same transport?
If you're swapping to a different server, you're definitely doing a new handshake because it's a new ICE, UFRAG, all the other things. So you should not be it should trigger a new handshake, and you should demultiplex based on the underlying transport.
Yeah.
So it's essentially interrupt with what states in SDP, but I'm not sure that's implementable.
But in that case, if the ICE flag and user password changed, do we need to reuse same ICE transport, do a restart on the ICE, or create a brand new ICE transport for that? Because if we do ICE retarget using the same ICE transport, and that probably require us to be able to do two different DTLS on the same ICE transport.
Again, it's most likely a new ICE transport.
Then actually, this one may be related to the previous slide about ICE restart. For this hopping to a different server scenario, we allow both, or is there any kind of recommendation which way to go?
Well, essentially, what will happen in this case is you should get a new offer from the server with a new UFRAG and password, which is new handshake. So if you have an ice gatherer which is still warm, you can reuse that, but in other cases you need to basically gather candidates from the scratch.
Yeah. So we're basically, are we everyone okay with throwing the invalid state exception on this one?
Yeah, agree.
Okay.
Does that mean it's permanently blocked from being able to do it, or does that mean it's just you have to call stop first? I just want to be clear.
Yeah, I think you basically have to call stop.
Okay, so it is allowed to start a new DTLS transport, but you have to call stop first, just to be clear.
Yeah, you have to call stop first.
And if we have a late packets from the previous stream still coming in, how are they going to be handled? Or is it something which needs to
Well,
be
if it can't be
handled in ATF?
They won't decrypt, that's for sure, at the very least.
Well, we talked about, yeah. I mean, it could force a retransmission or something.
I mean, you already have sent a close notify to the other side when you close the first, DTLS transport, and so any packets in flight on the new one, will get processed and discarded, and hopefully they won't trigger, any sort of thing that will actually put the new DTLS transport into a bad state. I guess like when we actually implement that, we can figure out what needs to happen there.
Ideally, some sort of, ideally what we need is some sort of DTLS extension, but that's a separate probably discussion. There need to be some sort of identifier of which flow this is.
Well, we just need to, if we get encrypted payload packets that are in flight from the old thing. Yeah, I see what you're saying. That can be kind of messy, because then like if they send a close at the end of their session as well, will the new transport immediately get closed? It would have to ignore everything prior to a new handshake, but it might do that anyway. Anyway, this sort of seems like we actually have to implement some of this stuff before we can understand exactly what needs to happen.
Yeah, I was basically trying to. I couldn't figure out the way to do it consistently, so that was the reason why I kind of started asking questions. So that's, but maybe somebody finds a better way of dealing with this.
Okay. Okay. Matching rules. There's a warning. This conversation is going to get pretty complicated, and we're only going to try to deal with a couple of use cases, and hopefully we'll even get through those, but maybe not.
So, hold on. How much time do we have left?
Not a lot.
15.
Okay.
Enough to make people ill, but not enough probably to conclude anything.
Well, I sent out one email pointing out that, like, at some level we have to do the same thing as WebRTC 1.0, right?
Yes, I was looking for the reference, and I couldn't. Maybe I just wasn't looking hard enough. Are these rules actually laid out in the document, and if so, which one?
I'm not sure if anyone ever laid them out in as much detail as we were trying to here.
Yeah.
I think it was more at a high level.
Basically has to work the same way, but the question was, what exactly that was.
And I think at a high level we are, but when it comes to like the SSRC latching with payload types, like, I don't know, WebRTC 1.0 is nailed down and what hasn't. Do you know, Justin?
Yeah, so it'll probably come back to me if we can actually see it, but like I think that most of the stuff is written down in JSEP.
Oh, okay.
Okay, well, let's look at these rules at least and start getting our heads around it. And we might have to do a follow-up meeting at some point to really nail this down, or take it to the list, certainly.
Why don't you take over, Robin?
Okay, next slide then. So basically, you have RTP packets coming in, and they'll have an SSRC. They may have a MUX ID, which is optional, and they will certainly have a payload type. So the question is, when you receive one of these packets, how do you know which receiver to give it to, or when to throw an unhandled event? So Peter came up with a proposal, and we've been hammering it back and forth since then, and trying to come up with exactly how it should work. So the idea. Peter's basic idea, although there has been some modifications, that there's 3 tables. There's an SSRC table, there's a MUX ID table, and there's a payload type table. And basically, each one of those has a mapping. For the SSRC, when you see a certain SSRC, it must go to this receiver. When you see a certain MUX ID, it must go to a particular receiver. Or when you receive a payload type, it must go to receiver. And your receiver object would basically specify only one of these options as its primary mechanism. So if you go to the next slide. The idea here is whenever you call .receive on the receiver, the idea here is that you're creating these mappings in those tables, and whenever you call .stop, you're removing the mappings from these tables. And once the RTB packet is then routed to the correct receiver based on these primary tables, it's up to the individual receiver to then use the correct encoding parameters based upon SSRCs or payload types or whatever happens to be in the various encoding parameters from that point on. But the whole matching rules is all about getting it to the right receiver. So we're not really talking about that issue. So next. So the RTB packets are checked in this order. The primary source is the SSRC table, and then we go to the MUX ID table, and then we go to the payload type table if none of those entries exist. So if a MUX ID entry is found, then it creates an SSRC entry implicitly to the same receiver, and then anything with that SSRC automatically matches based upon the SSRC table rather than the MUX ID table, because the MUX ID actually gets dropped off after a period of time. We don't keep repeating the MUX ID forever. The payload type has a similar behavior where we create the SSRC mapping, with one slight difference, and that is whether we remove the entry from the payload type table after we've seen that payload type, or whether it's maintained forever, and there's a little bit of debate over that particular point. So that's what we're here also to talk about. So next slide. Sorry if I'm rushing, but kind of have to. So the questions we have to answer, and we're going to run through some of these use cases to be able to answer these, hopefully, is what are the impact on common use cases, and we certainly have to factor in what SDP allows currently, and certainly what a WebRTC 1.0 allows, and whether we should be removing entries from the payload type table when we see that particular packet type, and if we should remove entries versus maintaining those entries forever until stop is called, should we remove all payload type mappings or just the one that's seen? And there are implications depending on how we answer these on the use cases. So we have to actually run through some use cases to really understand what the implications are to all of these answers. So next slide. So I'm not even sure if this is legal or not in SDP, but it certainly could be done, and I'm not sure whether we want to support it. So we're not using the MUX ID in these cases because MUX ID really solves the problem and it's really fantastic, but we're not. So Alice constructs a receiver with Opus being mapped, 101 being payload type being mapped to Opus. Bob creates the first sender, uses 101 for Opus, it has an SSRC of 5000. Then Bob creates a secondary RTP sender, also uses 101 for the payload type, and uses and the SSRC that comes in is 6000. So basically, in this scenario, Bob is using two RTP senders, both with just specifying the payload type as 101 for Opus, and Alice has constructed one receiver with Opus only. The problem is with our PT table entry remaining in there forever is that both of these streams from Bob will end up going into the same receiver. Now, this we could consider perhaps illegal, or we can say we want to support this, or we can say that we don't want to support this.
Well, if it's only, since the receiver can only output one track, right? The receiver can't deal with these two streams coming in, right?
No,
it's not expected to mix them or anything.
No, it can't mix them, and it can't handle it. And this is not a simulcast case where it's switching between the streams. This is literally two senders end up going to the same receiver. So I'm not even sure this is legal in SDP in the first place, because I believe SDP requires, in this case, you specify the SSRCs, but I might be wrong. But if it is legal in SDP, then we got a problem. And if it's not legal, then we're probably fine to say don't handle it.
This actually is a very simple SDP example because it's just an offer with payload type 101 of Opus and an answer with payload type 101 of Opus, right? No SSRC specified, but suddenly 2 SSRCs show up.
Right, because the sender is sending literally 2 streams to the same M line.
And they have the same MID, apparently.
Well, the MID isn't applicable here because this is the use case where we don't even specify the MID.
Yeah, but yeah, it would because it's just one M line, right? But the guy starts sending 2 SSRCs.
Right. So I think this is where we fire the unhandled event.
Well, that's the question. That's what I would expect, but the matching rule determines, right? And if you were to get rid of, if you dump the payload type once you have the SSRC latch, then it would fire the unhandled event?
But if you didn't, it would go to the same receiver and then have decoding problems.
Well, I guess this, yeah.
I mean,
that's the issue.
You could get the wonderful thing where, like, basically they're interleaved, where you get a sample from 5,000 and a sample from 6,000, all feeding to the same output media stream track.
Yep.
That's yet another case, yes.
It's hard to say because not in this WebRTC world, but in the old this kind of SIP SDP world, there are certain kind of gateways indeed doing this. Actually, they change SSRCs. It's not like they overlap. Probably some kind of forwarding happening in the backend. So they use one SSRC for a while and then switch to the other one.
And switch the payload type at the same time, or same payload?
Same payload type. I think some typical co-manager does this.
In theory, if it was actually switching streams, it wouldn't be as bad because you would just have a minor overlap, which you could probably handle. But if it's maintaining 2 streams, then you really got a problem.
Well, it's very common to switch SSRCs without any indication on SDP for like a lot of legacy PSTN and other scenarios.
Right.
I agree with that, but I don't know of a case where it's maintaining those streams. And that's why I'm wondering, is this even legal and should we support it?
Yeah, the problem is, though, right, if you're changing SSRCs, you now have a different sequence space, right? So they can just overlap. I mean, how do I even know?
Right.
Well, if you assume it's a change, then you can know that, okay, now we're seeing a new SSRC, so therefore I'm going to latch the new SSRC and forget the old one and discard a few packets for a while. So it's handleable, but then you could come back as well. Like you could go to 5,000, go to 6,000, come back to 5,000, go back to 6,000. It can keep swapping back and forth. It can become problematic.
The only other scenario where I see this happening is if you're going through some sort of media proxy and then end up connecting to something which is portal, where you actually end up with 2 calls to 2 different people coming in. And I think the original way of handling was to decode both and mix them. Or pick the one you like.
The RTP rules say that they should be treated as separate streams, and therefore you can mix. But again, what do we want to do? So.
Yeah. So I didn't see the problem with, well, so I think there's a couple of different ways you can handle this. But remember, the browser, if they go to 2 different receivers and they output to an audio tag, the browser can mix them. So it's not like doing it that way necessarily prevents you from doing some of the stuff people just talked about. All we're saying is you just can't have 2 tracks coming out of the same receiver.
Yeah. So if we did remove the payload type out of the payload table, it would solve it because it would fire an unhandled event, in which case you could set up a new receiver and you'd be perfectly happy.
Yeah, the other thing we talked about briefly, Robin, and I don't know if it's we can decide whether it's legal or not, is whether you could have 2 receivers both with the same payload type, and like you latch one of them and take it out, and then when the new stream comes in, you latch the other one, so you don't even have the unhandled event.
Yeah, you could in theory set up 2 in advance. That's true. But regardless, this is the implication for removing the payload type out of the table or not.
But this is still a problem even if the new sender has payload type 100 for some other codec. We basically have 2 streams arriving at 1 receiver.
Yeah, I mean the difference, Justin, would be in that case the SSRC might not change, or it might change, right? If it doesn't change, then at least you have a consistent sequence space and you can know what's going on. As
Well,
opposed to having 2 sequence spaces.
I mean, I think just the problem here is we have 2 distinct streams arriving at one receiver, and this is a general problem. That the fact that they have the same payload type is just like one special case. There can be other cases, and this kind of gets back to the whole media discarded thing we talked about before.
Right.
So if I can interrupt, I was reading the Unified Plan document, and it seems like it has no rule for latching to SSRC at all. It basically just says if you don't use the header extension or SSRCs, then you have to have non-overlapping payload types. And if you need more than that many things to demux with, then you have to use the header extension or SSRCs. So what we could do, if we want to match that behavior, is just don't do the SSRC latching, and then make it an error to have so many RTP receivers with overlapping payload types that don't use the MUX ID or SSRCs for demuxing. Does that make sense?
Yeah, it could be made an error situation, or like I said, it could be that you do this removal process and solve it that way. So it's really what we want to do here.
At the very least, I want to be able to handle the switch of SSRC in the same payload in the most transparent way possible. Like transmitting 2 of them, I understand it's a problem, but there should be a way to handle the SSRC change.
As long as, in the case where you don't have any payload type overlap, and you're not using header extensions or SSRCs for demuxing, then everything would work fine where you're switching between SSRCs. It's just if you have overlapping payload types, that's when it.
I'm not so sure that it is so clear. Like if you're in both cases on open.
We should maintain a sequence space for each SSRC. So in theory, RTP can handle it. It's just about how we handle the payload out of those 2 RTP strings in the same session.
Right, the RTP can handle it, but not necessarily the receiver. That's the issue.
Yeah, if the receiver chooses to mix, maybe okay.
But if you use 2 different receivers, there would be no concern because it would just be absolutely clear that they're different streams, different SSRCs. There's no problem. But if it is the same receiver, it might be problematic, and you'd certainly have to handle those overlaps.
How would you summarize where we stand on this?
I don't think we have a conclusion. I think we need to take it to the list.
Yeah, I think we may have a 1.0 compatibility issue too. I think we kind of have to summarize what you're supposed to do in 1.0, and I don't think we can really do anything significantly different without creating problems.
Yeah, that's kind of what I think too.
I think fundamentally we need to understand what happens when you have multiple streams showing up at a given receiver. Like we sort of punted on that before. We still had to go talk to Martin. I think once we have that issue resolved, we can come back and think about what needs to happen here.
I would agree with that.
All right. Yeah.
So let's do that and punt it to the list at this moment, and maybe have another follow-up call at some point in the future.
You guys want to talk about audio codec switching quickly, or
no? It's all
related.
Okay.
Yeah.
Just to be clear, what you mean by stream is encoded stream, right? Not RTP stream.
Correct.
Okay, at this time I'm going to refer to the minutes for action items. So, Michael, did you capture all that?
I'm not sure. Why don't you type in what you think the action items are?
Maybe I'll leave that for Robin and Bernard to do, as I'm kind of driving the deck here. I just want to make sure that we're capturing it. So I'm also recording this. I got the majority of it. I think I'm about 5 minutes into the presentation, so we should be okay there as well. Questions for the community group. Are there any comments regarding the deficiencies of the ORTC API at this time? If you're looking to implement, it'd be a great time to speak up.
Do you have anything to say, Eric, about the status of ORTC Lib or any of those implementations?
Sure, I can speak quickly. We're kind of out of time here, but I'll just speak quickly to the ORTC library that Hookflash manages is we're about 65% done, and we're seeing considerable interest in moving that along. So we'll be pursuing that, and that should be happening in short order here. There's also been some great advances from the Microsoft side. So Bernard, thank you for bringing it up. I think we spoke to it on the last meeting as well in terms of the kind of forward momentum that we're seeing from Microsoft in their announcements around ORTC for Internet Explorer, or coming out of the Internet Explorer Modern APIs department. So probably leave it at that unless somebody else wants to make comment from the Microsoft side. I'd also like to just spend a minute hearing from Justin and Peter, or Peter, in reference to what we might see next. And I know that we're focusing on 1.0 in the WebRTC working group, but it'd be interesting to know what we see coming down the pipe in terms of a Chrome. If you can speak to that publicly in terms of what you guys see shipping next.
So I want to add a question about the shims. I wanted to ask about that. But for right now, I think what we're focused on is getting the right stuff into the 1.0 spec. The pieces around the RTP sender and receiver. And then some of the pieces that are specifically missing, and causing a lot of pain right now there, like the inability to change out a track, or the send and receive a track, or do replace track. Adding that functionality first. So that's kind of the path we're on right now.
Cool. Could you speak to, I know there's a bunch of pull requests that are kind of pending for 1.0 that incorporate ORTC API elements. Is that kind of in the same vein in terms of what you just spoke to?
Yeah, that's exactly. And that's actually been going a little bit slower than I would like, and not for any reason other than just just the complicated sort of process.
Okay.
And but it's actually a high priority for that editor team right now. So they are, I know, working on trying to get that thing. The big pull request for the doohickeys landed, immediately. And then there's a whole bunch of things, basically behind that Peter and I have been working on. That hopefully we'll be able to go in very quickly once that gets out of the way.
Oh, awesome. So is it your kind of impression that we'll see those pull requests happen before 1.0? The recharter for 1.0 happens?
I haven't been following the exact timeline on that, but I expect that stuff I'm hoping that all those things will be done by by the time we meet up in ITF in March. All the things that were kind of action items from November will be resolved.
Awesome. Okay, thanks for that. Does anybody else have any more comments here? Okay. Here are the references that we made earlier. There's a reference here to JS shims that is rather vacant at the time. If anybody is interested in taking on some of this work, the down shim and up shim work from 1.0 to ORTC. Oops. God. Sorry about that. We'd certainly like to hear about it. You can send an email to the public list, or you can send an email to me, Eric at hookflash.com. There's been others that have been interested in this work, so if anybody else is interested in getting involved with that work, we'd love to have a conversation around that. ORTC specification, create params, filter params, replacement equivalency can be found in the spec. The node implementation, Not sure where we are there. I think that might be a placeholder for work to come. I know there's interest there as well, but I don't think there's been much advancement made there. And then we've already spoke to the modern API, and we spoke to Google's progress on ORTC integration.
Yeah, Eric, very quick for the IE part. You might want to update that to in development.
It's under
Oh,
development.
yes, sorry. Our mistake. This is an older slide, I think, that we just duplicated, so thanks for that. Under development it is, and we're very happy to see that. Thanks, Shijin.
Do we have, so on the shim stuff, do we have any sort of test jig or anything that kind of, the shims are, being exercised right now? Basically, the reason I'm asking is I want to make sure that, AppRTC works well on IE. And, if we have the shims kind of working well in advance, then we just have debugging to do. Otherwise, we'll have a bunch of work to do.
Yeah, so I think right now there's not enough code and enough shape to get that done, but it should be an important item to do.
I think that's a mandatory requirement for the shims when they come out, but there's not enough of anything in there really to be useful at this point.
Yeah, so I guess it's the first step is to get the code in shape enough where that could actually run.
Yeah, I was thinking that if you just have like some mock object. Go ahead.
Let's schedule some time, maybe kind of March timeframe to get better and test Chrome and then IE with the same beginning.
Okay. Is that so? You're still on track for that?
We're on track, yeah.
Great. Well, what else is that we get the shims working on like mock objects, to have fake, JavaScript, objects that the shims are running on top of, then we'll at least have something that can be fired up, and see if it runs on ORTC. But anyway, I mean, just an idea. I'm just
comment there. I'm working with Dom from W3C to extend the W3C test for the pure connection API. He did the GUM and the media stream part to test against the spec, and by the end of February or at the latest in March, before we go to the IE meeting, that test should be almost complete. So that will be one of the tools maybe to test the stream against.
Alexandra, I'm gonna interrupt you there for a sec. Your audio is coming in very faint. So if you could just speak up, I'm not sure what we caught of that last iteration there.
All right, let me try again. I was saying I was working with Dom from W3C to extend the W3C test of the JavaScript API. He did most of the get user media and the media stream and the tracks and everything. I'm working on the peer connection part. So there should be more. There should be a new tool to test against the machine against. And the ETA is end of February, beginning of March.
Oh, great. That's excellent. So would you be as kind to promote that on the public ORTC list when you've made some progress there?
Okay.
Awesome. Okay, anybody else?
Thanks, everybody.
Thanks everybody for participating. Special thanks goes out to Microsoft, to Google, and Robin for putting all the work in to making this last meeting happen. And thanks to Google for the opportunity to use Hangouts. Here's more information on the community group via the W3C site and the developer site. And we'll be in touch in terms of when the next meeting is going to happen, and the action items from the minutes and the recording will be posted soon. Thanks everybody for participating.
Thank you.
Thanks.
My name is Eric Lagerway, the chair for the ORTC community group. Welcome to meeting number 7. This introduction has been truncated due to technical difficulties.
So the next question is, what do you think about the time? So
My name is Eric Lagerway, the chair for the ORTC Community Group. Welcome to meeting number 7. This introduction has been truncated due to technical difficulties.